Hi, and welcome back to another edition of Mr. Whitaker's Science Notes. We're talking about physics, talking specifically about waves. You can't see me, but I'm waving to you. Hi. In specific, we're going to talk about light, and light is a type of wave, a specific type of wave. And we're going to talk about kind of how it functions, some of the things that it can do and cannot do. The two things you can see on the top of the screen here, it says reflection and refraction. There's a couple things that we'll talk about today in our notes. So in order to take these notes, I mean, you've already got the first thing going. You're starting to watch the video. Good job. You can't see me, but I'm giving you a thumbs up. Thumbs up to you. Then make sure you have the paper here. It looks like this. And this is where you'll fill in some notes, and this will benefit you guys in the long run. Hey, why don't you guys go ahead and sit back, relax, grab some popcorn, grab some candy. I just want to show you a quick video. So this is going to be a video within a video. Oh, very meta, huh? So if you can't hear the sound, it's okay because there's no talking or anything like that. It's more important that you just kind of see the visuals. And then one thing I'm going to have you do is try to think about when you're watching the video what your definition of reflection would be. What would be your definition of refraction? You can see those two words here at the top. The first visual that you see will be showing reflection, and the second will be refraction. And this is a very quick video. Let me show you fast. I hope you get to listen to the groovy music. Thank you for watching. Of course, you can't see me, but I'm dancing to the music. I don't know. I'm not sure if you can hear it or not. But so think about your definition of reflection and refraction. I'll just show it again real quick. I didn't say much during the video, but let me hit play here. So this is reflection, as you can probably tell. Laser pointer to a mirror, and this is what's called refraction. Sure, you guys have done this before. Sometimes you see it in the swimming pool. People enter the pool; they seem to appear different underwater, almost bent or broken. Sometimes even bigger. Sometimes they change size. All right, thank you guys so much. Now we'll get over to our notes, and I will have you guys think about your definition of reflection and refraction, and most likely you'll have to type it in using Edpuzzle. So the video should stop now. Hey, did the video stop, I hope? Well, it might stop again for another quick question about refraction. It might stop now. And we're back. I hope I was plenty annoying to you. Okay, so keep out your pen or pencil. Make sure you have this paper here. And I'd like to go through the slideshow as usual, and you can see our topic, reflection and refraction. If you're ready, don't forget to use that pause button. You can also reverse. You can go back in time to see like what I had already said. That'll be very, very helpful for you. Okay, so we have a couple essential questions today. And it says the first one is, how does light energy travel? Think about that one. Number two, how can the path of light be changed? I think we saw that a little bit in the video. And then number three, how does light behave after striking an object? Don't worry about the questions on the left here. Those are some typical questions that we usually get about, if you're a quiz today, what questions would you know the answers to already? What do you already know? And then what questions would you need to learn more about to answer confidently of those? So let's get to it. Reflection, refraction. Properties of light. These are a couple things that are properties of light, the reflection and refraction. So what is light? Light is a type of energy that travels in a straight line until it strikes an object. Light is a type of energy. And if you remember from the last section of notes that we did talk about energy and what that was, the ability to do work. What about light? It's made up of particles called photons. Photons. I believe there's a good joke about that. I can't remember it right now, though. You can look that up. You can hit pause and look up the photon joke. And last but not least, it says materials can emit. Emit means to give off. Reflect, bounce back. Or absorb. which means it kind of becomes part of the material. So materials can emit, reflect, and absorb light. Okay. Moving on, remember I know I go kind of fast, but use that pause button. Reflection and refraction, reflected light. So what is reflection? Reflection is light bouncing off of a surface, such as a mirror. Think about some other surfaces that light can bounce off of. The best objects to reflect light are very smooth because they reflect almost all of the light back. Okay? I don't know if you know this, but the light that we see when we see the moon, that's actually, there's nothing lighting up the moon besides the sun. It's the sun's rays, the light waves that are bouncing off the moon and coming back to Earth so we can see the moon. Moving on, reflected light, a rough surface such as water bounces the rays in different directions and scatters the light. You can see how it's rough. It's got all kinds of bumps and ridges. So it's just kind of bouncing those light all over the place, which can be good. Okay, different directions, it scatters the light. Reflected light. If reflection occurs on a curved surface, the rays reflect at different angles. This makes the image distorted or upside down. You've probably seen that in a spoon, as they show over here on the right. And then a little bit over on the right below that is the bean that you may have visited downtown Chicago. A curved surface can be concave or convex. A concave shape is like the inside of a bowl. So think about that for a second. I always kind of tell students to remember concave. If you think of a cave or something caving in, it would have like an indentation to it, right? It would have kind of a curve, and it would be the inside of a cave. So it kind of does something like the spoon, where they talked about a bowl. Whereas the convex shape is like the outside of a ball. So it's kind of round on a couple different sides. Okay, so that's convex. Concave, I think of something caving inward. Then convex, there's only two words, so I just think if I can get concave, I know what convex means. Moving on, refracted light. So what is refraction? Sounds like reflection, and almost looks like it too, but it's called refraction. So refraction is when light bends as it moves through another medium. So it might go through glass or water or anything else. For example, when white light enters a prism, it splits into the light into different colors. Here's the pencil in the cup demonstration. Is it reflection or refraction? And how do you know? Sorry, that's my clock. Brain work time. So hopefully you've come up with the fact that it is refraction. Rainbows are a type of refracted light. White light is refracted and separated into 7 different colors: red, orange, yellow, green, blue, indigo, and violet, known as Roy G. Biv. I don't know if you have a chance, if your partners or your classmates are on the same page as you, but it says talk to a partner and try to figure out what medium, which is a material, is refracting the white light into colors. Otherwise, just think about that on your own. I'm sure you could also talk to the teacher about it. Light and color. The color that we see is different wavelengths of light being reflected back to our eyes. That's what color is, different wavelengths. If you've done a simulation, what is it called? Intro to waves, I believe. When you look at the light portion of that, you actually see changing the frequency, which changes the wavelength as well. You can see that it actually changes into different colors. Black is a color that results from all the colors being absorbed, meaning no light is reflected back. And white is a color that reflects all light back. Those two are easy to mix up. So black is all the colors being absorbed. So it becomes like a very solid, a very dark color. But then the white, it's reflecting all that light back at you. Uses of light. Well, a laser is a concentrated beam of light. Lasers can be used to measure distances, carry telephone signals, and perform surgery. Lasers can be used in space. Ellen Ochoa, NASA's first female Latinx astronaut, studied lasers and their uses in space. Can you think of an example of when an astronaut might use a laser in space? Well, think about that on your own. We have transparency. Transparent. So if light passes through a medium and the items on the far side appear clear as through a regular window, the medium is what we call transparent. Now, another big word that's similar to transparent, it's called translucent. If light passes through a medium and items on the far side appear blurry, as through wax paper. The medium is translucent. You might have a shower curtain like that or a shower door. Some classrooms, I know mine does not have that, but they'll have some sticky substance on there that will actually kind of blur out the vision through there. And can you think of some other ideas too of translucent? We didn't really talk about transparent, but you can think about those as well. Opaque, if no light passes through a medium, it's like a solid wall or dark paper. The medium is opaque. Nothing's getting through. That light is not passing through. Okay? So it says identify the primary medium in each picture as transparent, translucent, or opaque. Justify your answer. First one you'll see in the upper left hand of all those pictures. I suppose it's just the bubble. Okay, so think about if that's transparent, translucent, or opaque. The answer, of course, is transparent. We can see right through it. How about in the upper right-hand corner? We have the mountains. We have the water. Water is very clear to see through. Thank you for your answer. That is translucent because it does go through, but it does change what you're seeing. Okay, there's a little bit different color, kind of obscures. We can't exactly see what's on the bottom of that lake, river, whatever that body of water is. Now let's look at the dragonfly in the lower left-hand corner. Hey, you're right. It is transparent. You can see right through the wings of that dragonfly wing. If that makes sense. All right, last picture, we'll see the brick wall. And you are so correct. How good? How are you this good? It's opaque. Can't get any light through there. All right. So think about this. A solar eclipse happens when the moon moves directly between Earth and the sun. Sometimes the moon blocks only part of the sun. Sometimes it blocks all of the sun. Look at this picture of the total solar eclipse. The moon is covering all of the sun, allowing us to see the sun's corona. That's the bright part around there. What property of light allows this phenomenon to occur? Think about that as we've talked about it. All right, now think about just checking for understanding here. We'll be on our way. So give your best answer to the following. How does light energy travel? How can the path of light be changed? And finally, how does light behave after striking an object? And do you have any other questions that you still need help to understand? Think about that. I'd like to conclude our little note session. If you probably noticed, this is a little bit less notes than we took last time, so that's always a plus. I hope you guys had a good time listening to the video. I have a great time teaching you guys. I'm Mr. Whitaker. I'm signing off, and yeah, make sure you check with your teacher to see what you can do next if there's still time left in class. But yeah, again, signing off, and go science. Thank you so much.